Alrighty, good afternoon, everybody. Happy Wednesday. Unfortunately, the Teams meeting went great today. I was recording, but it seemed to have, due to technical issues, crashed in the middle of it again. So I'm re-recording this for you guys to summarize what we talked about in today's Teams meeting. So let me start by sharing my screen with you guys. Okay, so you should be able to hear me and see me. And so the first thing I talked about today was there is a new opportunity that's posted on my website. And also you should have received it through an email that I'm going to be starting a series of guest lecturers, former students from Sturgeon or Silver Heights who went on in computer science to study it at the university level or are working in that industry or a related industry. And what they're going to do is they're now going to give some guest lectures on this stuff. They'll be delivered live over Microsoft Teams, and you're welcome to attend those meetings and learn from them and ask questions and really enjoy, learn, and get some motivation, because these guys and gals were once you. They were students in my class who then went on to pursue computer science beyond high school. And so I thought they could offer some great expertise on specific topics. So rather than me be the lecturer, these are people that are working in the industry who have way more experience and way more knowledge in these areas than I do. So I'm super excited about this. They're going to be great. I'm going to record them and then put them on my website if you're unable to tune in live. So that's the new thing. There's a form you can fill out. You see it's listed right here. If you have the time and if this is interesting to you, all the form does is it once again restates all that. And it basically says, what topic would you be interested in about hearing? So I can share that with my alumni and say, this is what the students are interested in hearing about, or this is a question they had that they'd like answered. They've already proposed some topics. So what I've also done is taken the topics that they've proposed and given you guys a survey into how interested you are in those topics. So designing software, maybe I'm just interested in that. Intro to C or C++, so I'm not really interested in that. 3D graphics, I'm very interested in that. So this way I can share that information with the alumni, and then it'll help them to design their lectures based on what you guys want. So that was just something I mentioned that everyone got an email about. The very first lecture is set up for this Friday at 1 o'clock, and you should have also got an email about me for that. All right, email me if you have any questions. Today in our 40S class, what I want to focus on is to continue looking at the collections example. Okay? Continue walking through that. This is what we started last week, so if you want to learn more about collections, you should watch the videos, read the presentation. If you need the code, you can download the GitHub example. Okay, so you should be looking at the presentation, watching the formal videos of me teaching it in class. And if you need the example, you can go right on GitHub and just download what we did right up to the yesterday, or even what's up on GitHub is what we did as of today. So that's all available for you. And then in the weeks to come, we're going to continue that definitely next week. And then hopefully we'll have time to do as well the collections assessment as well. That actually doesn't take too long. It's not a very detailed assessment for collections. That will be the end of the last unit in this 40S course. So from that point on, for the remainder of the course, it'll be time to talk over those last few weeks up into mid-June about how to finish up this course. I mean, the traditional way is a final project, which I know some of you are definitely going to do and you're definitely going to be excited about. It's not really something that's going to be graded the same way that it has in the past, obviously, with your marks frozen. But I'd like to see you guys do some sort of final project. If that's something you can't do because of time or technical issues, then there are other ways you can summarize your course. Like you could just write something. But we'll talk about that stuff in the weeks to come. Okay, so on to today's content. Once again, looking at our giant example, we are now going to be working again on the collections test And we've already completed the node class. It's done. So we'll continue to add more and more methods to the linked list class and then test it in our collections test. Okay. Our linked list already has a ton of useful methods and things inside of it. So you can see here a bunch of add methods, a bunch of the head and the tail, and all these neat methods that we'll be creating today will be part of the linked list class. In our testing class, the last thing we were testing was inserting random things using the add after method. And before that, we were using the add before method as well. So we had add after and we had add before. And that was actually a bit of a bug by the end of the class on last week. But I've got that all fixed now. So if you need that code, it's in there. And what I've done is picked a random spot to do it. Anyways, I'm going to run it and show you what it looks like before we add any more code. There you go. So since the beginning of us looking at linked list, we started by just testing, make sure nodes worked, checking to make sure the equals methods of node works, 2 nodes are equal or not. Whoops. Cloning nodes using the cloning method, finalizing nodes, and I introduced the idea of a finalize method, which wipes something out. Then the linked list, testing if it was empty, testing to see what it looks like if we spit it out as a string, testing the size of the linked list. Okay, and then after that, we tested adding to the front and then adding to the back of our linked list. Okay, so adding things always to the front, to the front, to the front, to the front, or always adding to the back, to the back, to the back, okay, which is really handy. We then tested a get method or an accessor method, and we tested a set method or a mutator method. And we even tested it beyond the edges, right? So we're setting or changing a certain spot, but we tried to change a spot that doesn't exist. We tried to get a spot that doesn't exist. And unlike arrays, it didn't crash. It just returned a null value, or it said, no, I cannot set spot -1 to -1. No, I cannot set spot 10 to be a 10. I'm not going to do that. We then tested our clone method, where we can clone one linked list into another. Then we tested to see if 2 linked lists are equal. Then we tested a finalize method with a linked list and then checked the equals again. So it was both true and false. And then we tested the big adding before and after methods, which we'd finished with. So there's the linked list and adding a 0 before spot 0, adding a 0 before spot 10. So this is testing the edges. Then we tried outside the edges, which shouldn't happen, which it didn't. And then testing random spots within the list to add before and then later to add after. And that's what our testing looked like at that point. So on to the linked list. Today, since we finished add before and add after, we're going to do another what's called a wrapper method. This version of add. Now we already have a method called add. So this one changes it by adding a second parameter. That's what overloading means, right? Same name, different parameters. So this would be like if you had a list and I said, okay, here's a list of 20 items, and I said, add this name Fred after spot 5. Okay, that makes sense. You'd know to put it after there. But if I just said add Fred at 5, okay, do I change 5? So what we're doing with this is we're saying whenever you add something and if you give it an index, you're going to call the method called add after. So this one method ends up calling another method, hiding the fact that that's taking place. Okay, so let's test that. Actually, no, we don't need to test that one because we've already previously tested this fully. And since this method just calls this method, it's already fully tested. All right, now the next method we wrote is a simple little method to access the very first, the head or the front data in the list. Now what it's returning is the actual data inside of what's at the front of the list. And so to do this, I just depend on that get method we wrote last time. So the accessor method gets spot 0, which is the front of the list. Okay, let's put that to the test, but since we're going to test it, let's also quickly write a back method that does the same thing. And the back method gets length -1. That should be the very last spot in the list. Okay, so let's put those two methods to the test. To do this, I'm going to create a third list. It's going to be empty. I'm going to create a fourth list. It's going to have only one item in it. So this allows me to test a list that has lots of stuff in it, a list that's empty, and a list with only one thing in it, which are kind of our testing scenarios. All right, so here was the code we wrote to test the front and the back of list 1, which is empty. Or no, list 1 is full of stuff. List 3, which is empty, and list 4, which has only one node in it. So let's run those tests and see what happens. Okay, so here you can see list 1 has got a lot of stuff in it. So and it says, hey, give me the front. It's at spot 0. There it is. Give me the back. It says it's spot 9. That works as normal. But what about if it's an empty linked list? Well, then both the front and back are nulls. There's nothing in there. What about a linked list that only has one item in it? Well, then the front is 9 and the back is 9, just like you'd expect. So it tests that linked list method pretty fully. And the reason why I did that is then the next method we wrote, remove the front of a linked list, relies on us, let's do it this way, us calling our front method. What is the front of the list? Okay. So this remove front method is dependent on that other method existing. So that's what you're going to find is now as we're getting a little more advanced in linked lists, the methods end up becoming dependent on each other, right? You're not starting from scratch in every single method. I mean, remove front was already dependent on is it empty or not? Because if it's empty, I'm just going to return null. There's nothing to remove. Then what I'm going to do is temporarily store the data by drawing it out of the front of the list. Because when I remove the front, I'm going to return what the data was at the front. Okay, so that's the first thing it does. And then comes a neat thing here. So I'm going to draw a little diagram as I'm doing this. So obviously if it's empty, I just say, yeah, there's nothing to return here. Then what I do is I temporarily store the data, whatever the data I'm going to be removing. I temporarily store it in a little variable just called data, okay? So right in here, it stores what's at the front of the list. Now let's assume we have a one node list like this. It's one node. This is a null. This is a null. Let's say it's got a 5 in it. So this line says, okay, get that 5 out of the front of the list. No problem. Then we come to this line. If the length is 1, well, a one node list would have a length of 1. So what it's going to do is it's going to finalize the list. Now remember, what finalize does is it sets head and tail. Head and tail are currently pointing to this one node, because that's the only list there is. It says, you know what? Make them nulls. This is a null, this is a null. It also, remember our linked list will be storing the length of the linked list where somewhere. It'll set it to 0, which essentially means this thing is now garbage and it's deleted. But I've still stored the data so that when I get down to the bottom of this list, I can return that data. But now the linked list is empty. All right, now though, what if, oops, I don't have a length of 1. Now what if I get into this code right here? Okay, so now we assume we have a list of more than one node. But one of them is at the front, which will be this one. Okay, then I have another node, and possibly a whole bunch more. It doesn't really matter. This node is connected to this node through the next node. This one is connected back through the previous to that one. The head of the list is still this thing. And I've already stored the data. That we've already talked about. The data is stored. It returns it at the end, so let's not worry about that. What I want to worry about is these lines here. Let's see how this works. Head is going to change now. The head, which was here, becomes head.next. So it becomes what head's next is now. So head now moves over to here. It's not this anymore. This is no longer what the head is. Okay? That's done. Now let's look at this next line. Head, so I'm here, dot previous, now I'm here, dot next. So it's a double reference. Head dot previous dot next means I'm talking about this thing right here equals null. So make it a null right there. I sever the connection to the rest of the list. But I still have a connection right here. So that's what this line's going to do. Head dot previous, that's this thing, also equals null. So that severs the connection. There we go. The length goes down by 1. So whatever the length was, let's say it was 5. Let's say there was 5 nodes in this list. Now it's 4, right? So there was 5, now there's 4. And then I just clean up any garbage, which is what this would be. This would be garbage memory, so the system would just clean that up and get rid of it. And now I have, in fact, removed the front of the list. Okay? Using that logic, we also then built a remove back method that essentially does the same thing. The only difference is, right here in these lines, I reverse the logic. So head becomes tail, previous becomes next, and next becomes previous as it switches the logic up. I could draw it all out for you, but essentially you should do that just to get a feel for how that works. And also, I'm going to get it from the back of the list, not the front. That's where I remove the back by drawing the data out of the back of the list. Okay? So this method is dependent on the method back here called back. So there's another dependency there between the methods. All right, let's test this stuff. So, first things first. To remove from the front, I'm going to output the list first, and then I'm going to keep looping through it and removing the front over and over and over again to see how that works. So let's see how remove front works. And there we go. So here's what the list looks like. And I said, hey, remove this front node 0. Here it is, and now it's gone. Then remove the front node now, which is the other 0. And now it's gone. Now remove this front. There it is, and it's gone. And it keeps going down and down and down. You'll notice that front node keeps disappearing off the front of the list till it's finally one list node left, and then it's empty, and then it still can go beyond that, and it doesn't crash. It just says there's nothing to remove because it's an empty linked list. All right. Now, we're going to test add back, but to do that, I'm going to make a clone, just so I don't have it, because I already have an empty list. So I'm going to make linked list 2 full again by cloning list 1. And now I'm going to test remove back, which should essentially work the exact same way, except now removing from the back of the list instead of the front of the list. Okay, so here's the clone. Here's me removing it from the back. So the 9's going to go, then the 0, then the 8, and you can see here that's exactly how it's going. Until finally it gets down to nothing, and then it still has no problem with that. Cool. The final thing we looked at today was incorporating these dependencies. We can remove, so let's go back to where we were, okay? These extra spaces. So we added, okay, we had the front of the list, we had the back of the list, 2 little methods there. Here's the front, here's the back. And we remove the front and remove the back, okay? So these were our little methods that we've started with today, right? A wrapper method. It hides the fact that something's going on. Add, front, back, remove back. And then the final method we worked on today was just a general remove method. Remove based on an index number. So whatever index number I'm given, remove that index. Okay, so here's some facts about that. First, it checks to make sure that this index number is in range. So if I have a 5-node list, I don't try to remove spot 50. That doesn't exist. So I just return a null. That's an error check. Then something interesting happens. If it's at index 0, and remember, I've already checked to make sure that the index is in range, well then why don't I just remove the front? Similarly, if it's at length minus 1, I'm just going to remove the back. So this remove method is dependent on the other two methods that we just finished, the remove front and remove back, which were dependent on front and back. So building these methods in a certain sequence makes sense because they start depending on one another. Okay, but now let's assume it's somewhere in the middle of the linked list. All right, so at this point I'm going to draw the diagram. So let's say I have a linked list with a node like this. Let's say there was a bunch of nodes in front of it. That doesn't really matter. Another node. Then another node. And then there was a bunch of nodes after that. Okay. This node is connected through the next to this one. This node is connected back through previous to that one. This one through next. Oops. Let's try that again. And this one through previous. Okay, the length of this linked list is stored somewhere. Let's assume this is an 8-node list. And this is spot 3, 4, and 5. And I know it doesn't store index numbers, but let's sort of assume that's node 3, 4, and 5 in an 8-node list. And let's say the index number I said to remove was spot 4. So it's in range. There is a spot 4. It's not spot 0, and it's not spot, 7, length minus 1, which would be the very last node. So now we get to this node. It makes something called current. Makes a node reference called current by getting to that index. So this is where current is. It gets to spot 4, which is the index. Right? It gets there. We already made that method. Now come some other lines, but then down to this one, this length will now go down to 7. That's an easy enough thing to realize. And it will return whatever the data is stored inside of current, whatever data that is, it will return this at the end of this method. So that makes sense. That's why it's returning this data right here. But it's these 3 lines that I want to really analyze what's going on here. All right, double references again. Current, that's this thing. Dot next, now I'm over here. Dot previous, so I'm talking about this thing right here. Now what it doesn't equal is null. What it equals is current dot previous. So it takes this and now references this thing. So it's essentially linking it around the node I'm deleting. That's what this line does. We're going to see that again in the next line. Current dot previous dot next is referring to this thing. It's not this anymore. What's it going to be? Current dot next. So in other words, this thing will now be linking over to this thing. So you can see here the references or the links are linking around the node that is being deleted or removed. However, there's still a connection here and here. So that's what this next line deals with. It says current dot next, that's this thing, equals current dot previous, that's this thing, and they both just equal null. So it severs those connections. So there are no more connections from the node that I want to delete, which is this node right here, and the rest of the list. It has been linked out of the list. And so by doing those 3 lines, understanding how references work, it will essentially remove that node out of the list. Okay. Wild. Let's test it. Now this is going to take some testing. So the first thing I'm going to do is, once again, I'm going to clone linked list 1 back onto 2. So 2 has some stuff in it. Okay. I'm going to output the list first so we can see what the list looks like. Then I'm going to try to remove the 2 edges. So I'm going to remove the very first index in the list, spot 0, and the very last index in the list, which is size -1, which should test these 2 things right here. So let's run the test at this point, see what that looks like. If I just try to remove the front and back of this linked list using the remove method. So remove spot 0, so it should remove this one, and it did. remove spot 15. So at this point, it should remove that one. And it did. So that worked. That test worked. Okay. Now what I'm going to do is I'm going to remove a bunch of random spots within the list. So I'm just going to randomly go through a number of times. So I'm going to go through a ton of times, pick a random spot in the linked list and remove it, that index spot. And let's see how that test runs. All right, so here it is. It said remove random spot 5. So 0, 1, 2, 3, 4, 5. It should remove that third 3. And look at that, there's only 2 3s there. And the 6 and the 4 go right after it. So it essentially did remove this spot right here from the linked list. So you can see there, it's gone. Spot 5 has been removed. And then it removes spot 2. So 0, 1, 2. So this spot would actually be removed. And look at that, it's gone. Then remove spot 8. 0, 1, 2, 3, 4, 5, 6, 7, 8. Remove that one right there. And it's gone. And you can go through and see that. And as it continues, it eventually gets down to one spot, and it removed it. And now it's an empty list. Okay. So why don't we make this go a little bit longer? I'm going to make that to a less than or equal to. So that it goes one more beyond that, so testing it even beyond the edge. And there you can see it tried to remove spot 0 from an empty list, and it just said, no, there's nothing to remove there. So it also works really well in that way. And that was it. That's where we stopped today. We stopped on that test. And that was our last method that we wrote there, the random method there. Pardon me, the remove method. And so that's it for today, guys. I'll see you next week, and hopefully our live session will be recorded live. But if not, I'll just do this again. See you next week.